So I'm going to do a quick debrief of the performance on assessment number 1, and I want to take a closer look at any items on the assessment that might have been problematic, and so that I can sort of get under the hood and take a look and see if something needs to be fixed, or ultimately if anybody's score might need to be adjusted because of some issues with the assessment itself and not with you, the learners. So here I am on for one section of the of the course this summer. I'm on the statistics page for assessment number 1. And here you can see the grade distribution for this class, and there are 16 grades reported in this section. And by the way, I compared section 1 to section 2 of the course, and the results are very, very similar, so I don't have to combine them to do this analysis. So here you see the distribution, and this is fairly typical of a graduate class where most of the scores are clumped together, kind of in the upper region, and then you always have a couple of scores. There's a bit of a break and a couple of scores that are significantly lower, usually due to some preparation issues or not being comfortable or enough practiced in a graduate experience or something like that. But this is very, very typical. I look at the mean score, which is almost 78%, and that's okay. I'm as an educator, I'm more comfortable when that mean is closer to 90%. But given this is a compressed summer class, that's not terrible. Standard deviation of 16% is okay. It means that the distribution of scores is not it's not out of the realm of normalcy. And that's kind of what you look for when you're analyzing test data is did the class respond normally? And if they did, okay. If they didn't, then there might be an issue with something with the assessment. But I do want to get under the hood with the questions themselves. So I'm going to go to the question statistics. So here you have the grade distribution, something that is represented here for each question. And I don't quite understand how this graph works, so I'm going to just go to the actual questions themselves. So here you can see on this screen questions 1 through 10. And this is the average grade for each of the questions. Nothing is completely out of the ordinary. I would look at question 10 and think 100%. That might have been really an easy question, or it could have been that it wasn't scored properly, or it could have been that it was something that everybody really, really got or understood. But honestly, to me, the most important number that I want to look at is something called the point by serial. And what this number reflects is a correlation number. So it'll be a number from -1 to 1. And it's the correlation of the average of how well students did on this item compared to how well they did on the other items on the exam. And again, this is a statistic that is used with the assumption that the students responding to this are doing it in in what would be a normal way, an expected way, I guess, is another way to put it. And anything honestly over 0.2 or 0.3 is absolutely fine with a point by serial. So when I just look at just the statistics on these questions, I can see that there's nothing unusual about that. I'll tell you what, I'm curious about question 10 and why everybody got it right. Oh, this is about deductive research, true and false. And so I guess this was something that everybody definitely understood well, or it was clearly written. But I am going to go to the next set of questions. Here I am on 11 through 21, and I'm looking again over here on the right, my point by serials, and I can see that I have 2 point by serials that appear to be somewhat problematic. They're in the negative range. And again, what this score represents is that people who did well on the assessment overall tended to struggle on this one. And notice the discrimination index. This tells you how well it discriminates against people who did well or not well, and it's 0. So this did not do a good job of discriminating between people who were well prepared or not. So I definitely want to take a look at these two questions more closely and then to see what's going on. You'll notice some of these questions have NA not applicable. You can't run a point by serial on a question in which more than one answer is correct. I'd have to, not more than one, but when you can select all of the above or select all that apply. The only way you can do point by serial is if you converted these questions to either to yes, the learner responded correctly to all of them, or they didn't. And I didn't convert those. So I'm not too concerned about those right now. Before I look at these, I'm just going to scroll down and look at the others. And they again, the statistics on these all look fine. Everybody got question 21 correct. I can look at that just to see if I think it's too easy, but I love it when people get 100% correct. So I definitely want to focus now on these two items. So I'm just going to pick question 14 first. Pull it into the window here. Okay, which of the following is the best example of an operational definition for the construct collaboration as it relates to student groups in the classroom? Okay, so if you recall, an operational definition is a definition that describes how do you know you have it and how do you know how much you have. So how do you know you have collaboration? So let's take a look at the three choices. Students work together to accomplish shared goals so they each receive the best possible score. Well, I don't really know how to me, I look at this and say, I don't know how students work together. How do you know they're working together? All students in groups cooperate successfully, associating with each other for a mutual benefit. It's a little ambiguous. I'll go to the last one. Students carry out assigned roles, stay with their group, remain on task, listen attentively, ask questions about things they do not understand, and monitor progress toward goal. Well, this clearly indicates observable actions that could be used to define what it means to collaborate. So of the three options, I would definitely say that the best answer is going to be that one, number 3. And then I look at the grading, and the grading indicates that that is the best possible answer. So let's take a look at the distribution of scores on that one to see. I have to go to the statistics on that, and I will for the question detail. So I click on that one. Oops, excuse me, I know we're jumping around a lot. I'll go to question 14. And you can see that of the 16 students, most responded well, got it right. So I'm happy with this grade distribution. What the point by serial tells you, which is interesting, is that the students who thought this was the correct choice, the 4 students who thought this probably did well on the other part of the test. And so it added to a low point by serial. But again, since the average score for this is pretty high, I'm going to say that this one is okay. So let's take a look then at number 15, the statistics on it first, and what the question is, and then I'll get under the hood on that one. Again, a similar who got it correct, number of correct, but we'll look at that in a second. So here's the question. Which of the following related statements is a hypothesis as opposed to a proposition or prediction? So I'm going to look at these two. Homework provides additional opportunities for students to practice academic skills, and because greater amounts of practice result in higher levels of achievement, homework leads to better test scores and higher levels of academic success. Well, just to me, when I read it, it doesn't sound like a hypothesis because I don't hear in that statement clear variables identified necessarily. At least to me, let's take a look at the other option. Students who are assigned and complete more homework, That's, to me, sounds like an independent variable. They earn better scores on tests and have higher levels of academic success than students who are assigned and complete less homework. So to me, the independent variable is clearly stated, amount of homework, and the dependent variable, scores on tests and academic success, those are two, to me, sound like clear dependent variables, and you're communicating or projecting the relationship, what you think the relationship is between those two variables. So to me, that is definitely the better answer. And if you look at the possible responses, that is the better answer. Let's take a look then at the statistics on that one item. I'll go to question detail, scroll down to 15, and we're sort of split. Most 11 did get the correct answer. Which of the following is a hypothesis? I would probably say that my guess is what threw the test takers, what threw you on this would have possibly been the word prediction, because this statement sounds like a prediction. It sounds like here's my variable, and this is what I predict is going to happen. However, a prediction would be more appropriate when you are communicating the parameters of an experiment and you're predicting what the data should look like in your experiment. This statement is much broader than a depiction or description of an experiment. So again, in this case, I would suggest that even though the point by serial is low, I don't see anything wrong with the item. I honestly, I would say that these two statements, if I could give a criticism of this item for me as the test maker, I would say that this statement, that the two statements sound a little too similar to me. But since 11 of 16 did answer it correct, or did identify it correctly, I think it's an okay assessment item. I probably won't use it in the future. But if this had been something like 5 people got it right and 11 didn't, then I would say it wasn't an item that clearly indicated the distinction between the two, given the way that it's written. Now, having said this, I do want to say that for those of you who studied well and you still picked the wrong choice, it's not completely on you. I admit 100% that these two statements are rather similar. And I think having had more practice over this, if I had provided more practice, you probably would have done better. But I'm just going to suggest that this item is also okay, and we will just move on from there. But this is what I do whenever I create an assessment and then I implement it. I always look carefully at the data for each of the items to make sure that they're functioning properly, because although I'm a very good assessment creator, I'm not perfect, obviously. And if you don't test things out if you don't pilot test them as an instructor, then you have to assume your items are not going to be perfect, and that students, if students are struggling on them, it could be the item and not them. It could be bad instruction and not them. It could be lots of things. So I do this. By the way, I teach another course on assessment in the graduate program that is something that helps you learn more about these kinds of things. So that's just something to think about. All right, on to assessment number 2.